So in the given problem, we are given a range of number from L to R. From L to R, L is the lower range and lower limit, and R is the upper limit. And in this range, every number will be treated as specially if it is a composite number. If it is a prime number, then it will be treated as it is. Also, if it is a so 1 is not a prime, but 1 cannot be factorized further, so 1 will be treated as 1 only. 2 is a prime, so 2 will be treated as 2 only. 3 also prime, but here 4 is not a prime. 4 have distinct prime number 2 only, so 4 can be factorized to a prime number 2 only. Okay, other than 2, no prime number is a factor of 4, so that's why 4 is represented as 2 instead of 4. In 6 we have prime number, since 6 is multiple of since is a multiple of 2 and 3, so here we can see two prime numbers 2 and 3, so 6 is represented as sum of 2 plus 3. So this is the notion that we are representing the composite numbers as a sum of their distinct prime numbers. Okay, so no matter how many times that prime number is occurring in their product, we will only take it as once. Okay, prime factor of 10 is 2 and 5, so it will be represented as 2 plus 5. And we have to add all these numbers. We have to add all these numbers and return as an answer. So I need to find how many times 2 is appearing, how many times 3 is appearing. So here you can see here you can see here 2 is appearing 1, 2, 3, 4 and 5. So 2 is appearing 5 times, so I'll add 2 5 times, plus 3 is appearing 1, 2, 3. 3 is appearing 3 times, so I'll 3 times. 5 is appearing 1, 2, so 5 is appearing 5 times 2, plus 7 is appearing 1 time only, so 7 times 1, and 1 is appearing 1 time, so plus 1 times 1. So this will be my answer. So I need to find the occurrences of prime numbers, how many times each prime number is occurring in the whole series. Okay, let's find out how we can deal with that. So let's say we have a series from 1 to 10 in which we know that 2 is a prime, so P represents prime. Okay, so P refers to a prime number. So P is a prime number, and now the question is how many numbers in the range 1 to 10 have 2 as a factor. So if in this range where we have number 1, 2, 3, so on to 10, how many numbers have 2 as a prime factor? Okay, so if we write the table of 2, we can write 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5. 10 is also existing. Beyond 2 times 6 is not existing in this range. So we can say that 5 times 2 is occurring in the whole range from 1 to 10. The answer of this problem will be 5. Okay, now how many times 5 is occurring as a factor? In how many numbers 5 is occurring as a factor? 5 is occurring as a factor in 5 itself, then 10. So answer is 2. So how we are finding that? If I consider 3 as well, 3 times 1 is existing, 3 times 2 existing, 3 times 3 existing, and all the numbers here upper number was the 10, so 2 times 5 was 10, and 5 times 2 was 10. Here 3 times 3 is 9. So the last number was also a product of 2, 5, but not 3. But if I divide 10 by 3, I got 3.3, and if I take its lower bound, that will be 3. So whatever the number I have, I divide that number with that prime number, I will get the occurrence of that prime number in the whole series. So in general, I can say that in the range 1 to r, if x is my prime number, then how many times that x is appearing in the whole series? What I'll do, I will divide this maximum number, upper limit of that number, with that prime number, and I take its lower bound, that is integer of that number. Since here I'm getting 3.3, I take its lower bound and I get 3. So that number of time that prime number will be occurring in the whole series. So what will be my answer? I have to do this for all prime numbers. Okay. So answer will be summation of n times p for all p. P is a prime number. So what I'll do, I iterate for all prime numbers. I start with 2. 2 is a prime number, and then I'll check how many times 2 is appearing. So if I find 2 is appearing n times, so I have to add that prime number p n times in my answer. Then I go for 3. 3, how many times 3 is appearing in the whole series? So I find n corresponding to 3, and then I add 3 that many times. Okay. So that will be answer for the range 1 to r if L is given as 1. But what if L is not 1? L is some value greater than 1. So here it is 1, 2, 3, 4, and clearly L is greater than 1. Our given range is L to R. We need to find the occurrences of all prime number in the range L to R instead of from 1 to R. So what I do, I know how to find the occurrence in 1 to R and 1 to L minus 1. So first of all, I find my required sum in the range 1 to R. So this is the answer if I consider range from 1 to R. And this is the answer if I consider range from 1 to L minus 1. So I subtract answer of this range 1 to L minus 1 from this whole range, and I will end up with answer of this range L to R. So I'm subtracting the answer of range 1 to L minus 1 from the whole range. Okay. So now till how many prime numbers I have to do is, so since we know that R is the maximum number, so we have to go for all the prime numbers which are less than R, which are less than or equal to R. Okay. So let's suppose you are given a Boolean array. So how we will create this Boolean array, that we will discuss later. But let's say I have given this Boolean array which is of length r plus 1, and this Boolean array have the information for all the numbers, whether it is prime or composite. If my number I is a prime, then if I plug that index I in my is prime array, that will retrieve me true. But if I is not a prime and I plug that I in my is prime array, that will yield me false. Okay. So what I'll do, I start with sum is equal to 0, and if my range is starting from 1, since 1 is not a prime number, also 1 cannot be factorized further. 1 is not a product of any prime number, so I have to deal 1 specially. 1 is a special kind of number. Okay, so if L is 1, I'll update my sum with 1, or I start with 0 only. Okay, now from I is 2 to R, I have to check for prime numbers. So for each number from 2 to R, if the number is prime, I plug that number in my is prime array, and if that number found to be a prime number, if that is true, then what I'll do, I find its occurrence by dividing maximum number r with I. This will be my n number of times that I is appearing in the whole range from 1 to r. So this is the answer from 1 to r. I am adding that I am adding that in my whole answer. Okay. Oh, and what is this? This is the answer from range 1 to L minus 1 that I am subtracting from my whole answer, minus equal to. So after the end of these two operations, I'll end up with answer from L to R. Okay, so then I'll return my answer. Then I'll have to return this whole sum as my answer. So that's all we have to do. So we have built up our solution when we have given this Boolean array. Okay. So now the next question is how to construct this Boolean array which have information of all the numbers from range 1 to R, which either they are prime or not. So the answer is sieve of Eratosthenes. So there is a famous algorithm, sieve of Eratosthenes, which creates a Boolean array for each number 1 to n, keeping the information that whether the number is prime or not in the range 1 to n. So what we do in this algorithm is we start with a by creating a array is prime, and we fill the whole array with true. Okay, so initially this array will say that all the number from 1 to n are prime. Okay, after later on we update all the number which are composite as false, but initially we fill the whole array with true. Okay, now let's say the range is from range of our number is till 15. So I explicitly mark is prime 1 equals to false. So in my array, this index 1 will be mapped with false instead of true. Okay, so I overridden this true with false. But after 2 till end, how will I do that? I start from 2. Okay, now from 2 I'll check what is the square of 2. Square of 2 is 4. Okay, so 2 times 2 is 4. So I'll do, I mark this number as false. So index of 4 will become false. Then I go further. 2 times I add 2 in that again. So 4 plus 2 is 6. So I mark that number as also false. Then I add 2 again. Okay, then I go to 8. I mark that also false. Then I go to next multiple of 2, that is 10. Then I go to next multiple of 2, that is 12, 14. So I mark all the multiple of 2's as false. 10 as false, 12 as false, and 14 as false. So all the multiples of 2 are marked as false because they are having 2 as their prime factor, and they are composite number, right? They are some multiples of 2, so they are not prime. They have to be marked false. Now in the next iteration, what I do, I start from the next unmarked number. Next unmarked number after 2 is 3. Okay, now in 3 I don't start from first multiple of 3 that is 2. 3 times 2 is 6. First multiple of 3 is 6, but 6 is already marked in the process of marking the multiple of 2. So what I'll do, I start from square of 3, that is 3 times 3, because after that because before 3 all the multiples of 1, 2 are covered. So I start with square of 3 till n. So from 3 square 3 is 9, so I mark 9 as false. Then next multiple of is 3 times 4 is 12, that is marked as well. Then 3 5 are 15 will be marked false. Okay, now I move on to next unmarked number. 4 is marked already, so I'll skip that. And now the next is 5. So I'll go for square of 5. Square of 5 is 25. Now 25 is not existing in this series, so I'll just skip that. Now that's 7. Square of 7 is 49. Again, that is not existing in this series. Square of 11, square of 13. So all the rest number which are not marked are prime numbers. So for each for each unmarked I, we have to go from I square till end. So I hope that you guys got why we are starting from I square till end. Because if I have marked all the multiples of 2, when I move to 3, the next multiple, the first multiple that I start with is 3 square, because 3 times 2 is already marked in the multiple of 2. When I go for 7 multiple of 7, I start with 7 times 7, because 7 times 2 is already marked when I'm marking the multiples of 2. 7 times 3 is already marked when I was marking the multiples of 3. 7 times 5, because 4 is not a prime, next prime is 5, so 7 times 5 is already marked when I was marking the multiples of 5. Okay, so on. So this is the way we can create our Boolean array is prime, and after that you guys know that how to deal with the original problem.